Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. In this course, we are going to be learning the Defold game engine, okay? We're going to learn right from the beginning, the basic building blocks of how this engine works, all the way up to scripting, coding, and then developing our first game. So, first of all, what is Defold? Well, Defold is a free and open source game engine. It's very lightweight as well. You could store it on a USB stick if you wish. It's a very lightweight open source game engine, and it also allows us to make both 2D and 3D games. And there is also a wide range of platforms that you can publish to, okay? Any platform you can think of, PC, Mac, Linux, mobile, consoles, it has the ability to publish to pretty much every platform, so it is a very versatile game engine. Defold is also a very clean and intuitive engine in the sense that its interface is fairly straightforward. As you can see here, there's a lot going on, but throughout this course, we are going to be understanding what each of these little panels do and how they contribute to us making our game. So what are we going to learn? Well, the first step is going to be learning the editor itself. So we'll be looking at installing Defold. We'll be looking at the editor overview, so understanding what each of the different panels and buttons do, and then we'll be exploring the concepts of game objects, components, and collections, which are the building blocks of the Defold engine. After that, we're going to jump straight into scripting, okay, where we will be learning the Lua language. Now, do be aware that there is no prior knowledge required of coding, so you can come here with a totally blank slate, okay? If you have no idea what coding is, or if you have no idea of how to write a single line of code, that is fine. We will be going from the very beginning, learning about variables, if statements, all the basics. Zenva is an online learning academy with over 500,000 students. We feature a wide range of courses, for people who are just starting out, or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included summaries, or follow along with the instructor with the included course files. Alright, now let's get started with the first lesson. Hey everyone, in this lesson we are going to be looking at installing the Defold engine. Now, to begin, we're going to go to the Defold website, which is defold.com, and then we are going to navigate to the top right corner where we have our download button. So we're going to click on that, and then that's going to navigate us to the download page. Now, there are many different platforms and ways you can download Defold. For me, I'm on a Windows computer, so I'm going to click on the blue download for Windows button. But if you're on a Mac, you can click on the download for Mac, and if you're on Linux, you can click download for Linux. And Defold is even on Steam, so you can install it there as well if you wish. But I'm just going to do a Windows install, so I'll click download for Windows, and that's going to begin the process of downloading the engine. Okay, so once the download has been completed, you should have a zip file, and inside of that zip file, we should have a Defold folder which contains our engine. Now, we're not going to be launching the engine from the zip, rather what we're going to do is we're going to get this Defold folder and extract it to somewhere on our computer. Now, you can extract this to anywhere, your desktop, your documents, your program files, anywhere where you want to store the engine itself. Alright, so I went ahead and extracted that to my documents folder. You can see up here, documents, Defold. And then inside of this, we have 4 different files. Well, we have a folder, a file, an executable, and then a little logo file here. Now, to launch the engine, we just need to double click on the Defold executable, and that should open it up. Hey everyone, in this lesson, we are going to be looking at setting up our first Defold project. So, when you open up that Defold executable, it's not going to open up the engine, but rather the hub or the launcher for the engine. Now, this is a little window where we can first of all preview all of our existing projects as well as create new ones, okay? Because when you're making your Defold games, you're likely going to have many different projects that you're testing out, that you're making at the same time. So having a nice central place to view all of your projects and manage them is going to be important, and that is what this launcher is for. So, what we're going to do is we're going to go on the left-hand side to where we have this new project button, and that is going to take us over to this screen here. Now, we at the top have 3 tabs, from template, from tutorial, and from sample. So we can create a brand new project from Defold in a number of different ways. So from template, basically here we have a number of different templates such as empty project, mobile game, desktop game, and so on and so forth. From tutorial, there are a bunch of tutorials that Defold have made themselves. And from sample is basically a bunch of sample projects if you want to basically see how certain features are done, or if you want to see how you can do a certain mechanic in the game. Now, for us, we are going to start very simply. We're going to go back to from template, and we are going to select the empty project right here. Okay, it's going to be a blank slate, and we are going to be filling everything in. Now, what we then want to do is go down to the bottom where we have our title, and this is where we can give our project a name. Now I'm going to call this one Intro to Defold, and then we can choose a project location. So you can click on these three little dots and navigate to wherever you want to store the project at on your computer. And once that is done, we can click on the blue Create New Project button. And here we are inside of the Defold editor. Now, in the next lesson, we are going to be going over exactly what this editor is, all of its different features, functionality, its windows. So hopefully, as we continue through this course, you'll have a good understanding of how to use the engine and be comfortable using it. Hey everyone, in this lesson, we are going to have an overview of the Defold editor. So when you open up Defold for the first time, it's probably going to look a bit confusing. There's a bunch of different panels, there's some text, you're not really sure what everything does. Well, in this lesson, we're going to break down what each of these individual sections do and how they can help you out in creating your game. So to begin, Defold is broken up into a number of editor panes, okay, or like windows or panels. And these can be seen here. We have the assets panel right here. We have the change files. We have the editor pane right here in the middle, this big one. Down below it, we have the tools panel. On the right hand side, we have the outline panel and then properties. So let's go through each of these and see how they can help us out in creating our game. So first things first, on the left hand side, we have the assets pane. Now the assets pane is basically a list of all of the different files that is inside of our project. Now this is going to look a lot like our file explorer. Okay, we have a bunch of different folders. We can open up those folders, and inside we can see files. So open up main, you see we have a main.collection file. Now, this is where we are going to store stuff such as our sprites, our scripts, our audio effects, our textures, everything that we want in our game that is a file. This is where we are going to put it, and this is where we are going to access it from. Now, down here in changed files, this pane right here, we're not really going to be using this at all, but this is just going to show us our changed files that we change up here in assets. And this is really only used if you're using Git source control. Now, this big panel here in the middle is known as the editor pane. And the editor pane basically shows us what our current file looks like when we are editing it. Now, right now at the top, you can see we have a README tab right here. So this is literally just a text file, a README text file. But if I go over into the assets pane and I open up the main folder, you'll see we have a main.collection. Now, if I double click on that, that is going to open up our main collection right here, which is where we can actually begin editing our game, adding in objects, and testing it out. But for now, we're not going to be doing any of that. But you can see at the top how we can switch between them. We can go back to the README, we can go back to our main collection. Now, on the top right side here, we have our outline pane. And the outline pane basically shows us the contents of whatever file we are currently editing. So you can see here, when we're in our main collection, we have a collection object right here, or a collection field, I guess you could say. Whereas if I go back to the README file, it switches down to a markdown. Now, once we start adding in objects and components, this is going to start filling out a bit more. And down here with the properties pane, this here is basically going to show us the properties of our currently selected item, okay? Now, once we have, like I said, our game objects and everything down, we'll be able to select them here in the outline list, and this can then show us things such as its position, its rotation. If it is a sprite component, this is where we'll be assigning the texture and assigning whether it's facing left, facing right, all those different properties we'll be switching down here in the properties panel. Now, down here at the bottom is where we have our final pane, which is the tools pane. Now, the tools pane has several different tabs: console, curve editor, build errors, and search results. Now, this is basically where we have a bunch of miscellaneous tools that can't really fit anywhere else. So the console is very good because this is where we can see error messages. So if there's something wrong with our code or something wrong with our game, this is where the engine will tell us and we'll be able to see exactly what's going on. And then we have the curve editor, which is used for creating curves. We're not really going to be getting into that. Same thing for build errors and search results. These are things that you can explore a bit later on. Okay, so that is just a quick overview of the Defold editor, having a look at the different panes. So once again, we have the assets pane, which basically displays all of our files and folders we have in our project here. The editor pane right here in the middle, this is basically showing us a look into whatever current file we have open. So if we have a scripting file, for example, this is where the text editor would appear. On the top right corner, this is the outline, and the outline basically shows all of the items that the currently selected file contains. And the properties is basically a deeper look into each selected item. So if, for example, we have our player, we can click on the player, and this is where we can see its position, rotation, scale, and all other properties that we want our player to have. And this is where we can, of course, modify them as well. Down here with the tools, this is where we have our console, which is probably the most important part, where we can see error messages and other custom messages that we might want to send to it. And then over here on the bottom left, we have our changed files, which is really only used if you're using git source control, which will show you the different file changes over time. So yeah, I hope you now have an understanding of what the Defold editor is and how we can use it. Now in the next lesson, we're actually going to get a start in looking at how the Defold actually works. Hey everyone, in this lesson we are going to be looking at the building blocks of our Defold games. Now inside of Defold there are 3 very specific things that we need to learn about before we can actually go ahead and begin creating our games. And these are the idea of collections, game objects, and components. Okay, these 3 things are basically going to be the essence of your game, and understanding what they are and how they can be used is going to be very important for when you actually want to jump in and begin developing your game. So let's go through each of these and have a look at what they are and what they do. So first of all, we'll start with collection, okay? What is a collection? Well, basically, a collection is a file which can contain objects and other collections, okay? Now, think of these as levels or scenes. If you've ever used another game engine, most game engines typically use the word scene to represent something such as a level, the main menu, level 1, maybe you have a credit screen. Okay, a collection basically holds all of your objects for that specific level, you could say. Now, like I said before, if you have a collection, you would have one for perhaps your main menu. You might have one for level 1, level 2, and then you'll be able to basically load in a collection for the menu. Then when you click the play button, you would unload the menu collection and load in the level 1 collection. And again, these collections basically contain what are known as game objects. Now, what is a game object? Well, game objects are basically the entities in your games. Okay, these are what are going to be filling in your levels, and it's going to be what you've spent a lot of your time working on. Okay, now a game object has a position, rotation, and scale, so you can move them around, rotate them, and scale them in your game to wherever you want. And they contain components which give the game object functionality and substance, okay? So without components, your game objects are basically just floating points in space with no real substance to it. Now, when it comes to game objects, you would use these things for your player. You would have a game object for your enemies. You'd have a game object for each of your little pickups. If you maybe have a health pack or a coin pickup, that would be its own game object. Obstacles as well. Now, let's look at components, which are basically what gives essence to our game objects. Now, you can see on the right-hand side, I do have a little preview here of an outline for a game. You can see at the top we have a collection, and then all of those cubes, those are game objects. And then inside of those game objects, you can see the B right here has 3 components. So let's learn about what components are. These basically give logic to your game objects, okay? Because like I said, without components, your game object doesn't really exist. It just is there in memory, but it doesn't have any substance. It has no visual. It has no logic behind it. And these components can be things such as sprites, colliders, scripts, sound effects, particle effects, etc. Okay, there's lots of different components that you can attach to your game objects to give them specific purposes and specific mechanics in your game. And what's great is a game object can have as many components as it needs to function. Okay, you can see here in the example, we have our B game object. Now, the B by itself, that game object, doesn't mean much. Okay, it only means something when we attach components to it. So you can see the components it has. It first of all has a script, which will basically give it logic to move around and collide. It then has a collision component, which allows it to have a physicality in the game space, and then finally a sprite, so we can actually see it on our screen. So those are the building blocks, the very basics of the Defold engine. Now in the next lesson, we are going to jump in and actually look at creating these things and seeing how they can work inside of our games. Hey everyone, in this lesson we are going to be looking at our building blocks of Defold in the engine. So in the previous lesson we looked at an overview of what collections are, game objects, and components. Now let's look at how we can actually create these and use them inside the engine. So to begin, let's look at collections, okay? So once again, a collection is basically like a scene. If you've used other game engines before, just think of a collection as a scene. It's basically a collection, as it says, of game objects. So you can basically use these as your levels. You might have one for the menu, which is going to contain your UI. You might then have another collection for level 1, which contains your player, your enemies, and your level geometry. And then level 2, level 3, and so on and so forth. So what we have open right now is a collection. Now, by default, when you create a new empty Defold project, you will have a main.collection collection available to you. Now to find that, we can go over to assets over here and open up the main folder. And inside of the main folder, we should see main.collection. Now simply double click on that and it will open up the collection right here. Now, when we have this collection open, we can go over to the outline pane on the top right corner, and this is going to basically list out all of the different game objects and components that are inside of this collection. But at the moment, you can see that we have nothing here, and there is nothing on this grid here, okay? This is where we'll be laying out our level, putting our player, moving our enemies around, but there's nothing at the moment. So what we need to do is create ourselves a game object. Now, to create a game object, we are going to go to our outline, we're going to right-click on collection, and we're going to go down to where it says Add Game Object. Now, a number of things have happened. First of all, our game object has been created and added to the outline list right here. You can tell it's a game object because the icon is this cube, whereas a collection is sort of a stack of these 3 boxes right here. Now, our game object has been given a default name of Go, which stands for game object, and since it is selected, down here in the properties pane, we are basically having a look inside of that item, inside of that game object, to see stuff such as the ID, the URL, as well as its position, rotation, and scale inside of our game space here. Now, inside of the editor pane over here, you'll see we have this little thing pop up, and this here is our movement tool. This allows us to move our game object around. Now, we aren't going to be going into detail on how this works just yet. We'll have a look at this in a future lesson. But for now, just know that our game object is selected and we have the ability to move it around, rotate it, and scale it inside of our game space right here. Now, like I mentioned before, a game object is basically just a container for components, because without any components, your game object doesn't really exist. You know, we don't really have a visual here, it's not really doing anything. So with components, that is how we add functionality and logic to our game objects, okay? For example, a player is going to have different components than an enemy, and a player is going to have different components than perhaps maybe a coin pickup or a level tile map. So how do we add components to this game object? Well, we can start by right-clicking on it, and then going down to where we have Add Component. And you'll see here we have a list of different components that we can add to the game object. Okay, we have camera, collection factory, collisions, labels, meshes, models, sounds, sprites. There's a whole bunch. Well, we'd go down here to where we have sprite and we'd select it. Now you can see that the sprite has been added to our game object here. You can see it's sort of indented a little bit, and we can open and close our game object like so. If we have, you know, for example, dozens of game objects, you probably don't want to see all of their components at once, so feel free to open and close them like so. Now this sprite, when we select it, you can see there's a large number of properties attached to this, and that's because this is where a lot of the logic for our game objects comes from, okay? So on Sprite, we have a bunch of different things. We can add a little positional rotation and scale offset. We can add an image, animation, materials, blend modes. There's a lot of stuff here for us to explore. But for now, we're just going to be looking at the basics of adding components and adding game objects to our collections. So you might also want to rename your game object. So let's just say we don't want it to be called Go. We want it to be called something such as our player, for example. Well, we'd click on our game object, go down to properties, and you'll see here we have an ID. Now, an ID is basically the name of the game object. So we can click here in this field and give it a new name of player. Hit enter. Now, you'll see we also have URL. Now, URL is very similar to a web URL, okay? When you go on the internet, you enter a URL to navigate to a specific web page. Well, with a URL in Defold, it's pretty much the same thing, okay? This allows us to access a specific component or game object inside of a collection with a given URL. So you can see here, our URL is currently /player. Whereas if I click on the sprite here, you can see the URL is /player #sprite. So we are basically saying that this sprite component is a part of the player, okay? We'll get more into this a bit later on, but just know that the URL is sort of the address for that specific item, and the ID is the name, okay? So we can also change the name of our sprite here. We might want to change this to maybe player sprite, although I'm just going to switch it back to be just sprite, as I think that's good enough of a name. Now, we can also go ahead and create more game objects. So we can right click on collection again, add game object, and maybe we want this to be a weapon. Okay, just like that. We can then maybe add, let's just say for this one, we'll add a collision object. We'll get more into collision objects and how they work a bit later on, but just for an example's sake, I'll just add a component right there. Now, something that's very cool about game objects is that you can have a game object be a child of another game object. So if I select weapon here, and if I drag it inside of the player game object here, you can see that weapon is now indented similar to a component, but this basically means that this weapon here is a child of player, and that basically means wherever player goes, weapon goes with it, okay? It's sort of like in a video game, if you have a character and you want to maybe attach a weapon to their hand, okay? You would make that weapon a child of their hand. So as their hand moves, so does the weapon. If their hand rotates, so does that weapon, okay? So that's basically what the child and parent relationship with game objects is. Now, we're going to get into this a bit later on when we actually have some visuals. So in the next lesson, what we're going to do is we are going to look at actually importing some sprites and setting those up to actually use inside of our game. So we have a bit of a visual, okay? So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be looking at importing some sprites and setting them up so that we can use them for our game. Now the reason why is because before we continue on looking at more of the engine features, looking at moving stuff around and going deeper into game objects and components, we need some sort of visual element that we can add to our game. So this is where sprites are going to come into play. So in the course files tab of this course, you should see a downloadable zip which contains the assets for this course. Now inside of that zip, if you extract it, you should see a sprites folder. Now this sprites folder contains two sprites, a coin and a player. Now what we are going to do is inside of Defold, we are going to create a brand new folder here inside of the assets pane, which is going to contain our assets. So I'm going to right click on our intro to Defold engine, our root folder here, and I'm going to go down to where we have new folder, and I'm going to call this folder our assets, okay? Now an asset is basically going to be anything that we add to our game, okay? Like a texture, a sprite, maybe even a script or a sound effect, any sort of file or piece of data that we want to add to our game files is going to go in assets right here. Now in order to subdivide this even more, I'm going to right click on assets and then go new folder and create one called sprites. And there we go. Is open up the file explorer where we have our coin and player sprites, and we are simply just going to drag them into that sprites folder. Just like so. And there we go. So now we have our coin.png and player.png inside of our game files, which is great. But how do we actually go ahead and use it? Well, let's go ahead now and create ourselves a brand new game object with a sprite component. So, if you want to pause the video for just a second, you can go ahead and maybe attempt that for yourself. I'm going to give you some time right now. Alright, and let's continue on and set that up. So, over inside of our outline pane right here, we are going to right click on our collection, and we are going to go add game object. Let's rename this game object here to be, we'll make this one coin. Oh no, we'll call it player. Okay, we'll call it player. And then we need to attach a sprite component to this player so that it can render a sprite. So we'll right click on player, add component, and then go down to sprite. And there we go. Now, what you may be thinking is, okay, we have sprite, then what we're going to do is go down to where we have our image property, and either click and drag player in there. That doesn't work. Click on these three dots here. You know, our player sprite isn't popping up. And the reason why is because we can't use these PNGs. Now, why is that? Well, first of all, Defold doesn't know what we want to actually do with these files, okay? Do we want to use them as sprites? Do we want to use them as textures? You know, what are we using these PNGs for? So we need to basically define these PNGs purposes for our game. And we're going to do that by creating what is known as a sprite atlas. Now, an atlas is basically one big mega image which contains a bunch of different sprites inside of it. And then what we can do is go ahead and set those up with our sprite component. So to create an atlas, what we're going to do is we're going to right click on our sprites folder inside of the assets pane. We're going to go down to new, and you can see there are a large number of assets that we can create right here. We're going to go up to where we have atlas right here. And here I'm just going to call this one out sprites underscore atlas. We can click create atlas right here then to create that file. And you can see once it creates it, it adds it to our sprites folder, and it also opens it up here in the editor. Okay, so our editor has now changed, as well as our outline and our properties pane down here. Now, what we need to do is add some images to this atlas. So to do that, we'll go to the outline, right click on the atlas here, and then go down to where it says add images. So we'll click on that, and then what we can do is basically just select which images we want to use. So we'll select coin, and then holding down shift, we'll click on player. So coin and player, click OK, and that is going to add it to the list right here. Now, how do we actually see them here in the main editor? Well, if we select our coin, for example, we can simply press F on our keyboard, and that is going to focus in on that right there. We can then use the scroll wheel to zoom in and out, as well as holding down middle mouse in order to pan pan the screen around, okay? So you can see here we have our player sprite, and then we have our coin sprite right here, which is great. Now, the next step is going to be saving this, so Control S on your keyboard to save that. Now, you can see if a file has not been saved if there is an asterisk next to it at the top here on the name, okay? But so far, everything here is saved, so we're good to go. Now, let's go back to our main collection. So if we click on main.collection up at the tab here, that's going to swap us back to that file that we are now editing. And what we're going to do is we are going to select our sprite component here. We're then going to go down to our properties, and we want to go down to the image property right here, okay? And we're going to click on these three little dots, which are going to open up the select resource window. We want to click on our sprite atlas that we just created, click OK, and nothing happens. And that is because we need to choose which sprite from this atlas we want to use. So the way we can do that is by going back to our properties, going down to where we have the default animation property. Now it does say animation, and that is because this can also work for animated sprites, but it just uses the one name for both things. So we're going to click on the drop down here, and you can see we can choose between coin and player. I'm going to select player, and there we go. Now, you may be either very zoomed in or very zoomed out. Well, just like in our atlas here, we can press F with the sprite component selected to focus in on it properly there. Now, the first thing you may notice is that if you're using pixel art, it is going to be very blurry. And the reason why is because the way that the filtering works by default is it uses bilinear filtering, meaning that the pixels are not going to be sharp and rigid, rather they are going to be smoothly transitioned between. Now, this is really good if you have HD sprites, but if you're using pixel art, it doesn't look that good at all. So how do we make our pixel art look nice and crisp? Well, for this, we need to open up our game's project settings. And to do that, we're going to go to our assets pane right here. And down at the bottom, you should see a file called game.project. Now, if we double click on game.project, this is going to open up our project settings here in a new editor window. And this is where we can edit basically everything about our project here, all the fine meta details such as the name, the version, publisher, developer, as well as a lot of the physics settings, platform settings, pretty much any background setting that you might think is here, chances are it is. So for us, we want to go to the left-hand side and scroll down to where we have the runtime category here, and we're going to go down to where we have graphics. Now, inside of graphics, we want to go over here and change our default texture min filter from linear over to nearest. Same thing for the next one down here. And this here is basically going to make it so that pixel art is going to be rendered nice and crisp. So now if we save this and go back to our main collection, you can see that our pixel art looks very nice indeed. So in the next lesson, we are going to be looking at our game objects and how we can rotate, position, and scale them inside of our game space right here. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at how we can move, rotate, and scale our objects inside of Defold. Now, these three tools are going to be very important, and we are going to be using them pretty much throughout in our entire journey with creating games in Defold. So let's have a look at how we can do that. So what I'm going to do is I'm going to select our game object. Now we can do that by selecting it here in the outline, or we can just click on it inside of our editor pane window right here. Now, when we select our game object, you'll notice that we have this tool appear over the top of it, okay? And this here is our move tool. Now, you can see the list of tools at the top right corner of our editor pane. You can see here we have the move tool, then we have the rotate tool, and then we have the scale tool, okay? These three tools right here. Now, keyboard shortcut, we have W for the move tool, E for rotate, and R for scale. So W, E, R. Now let's have a look at the move tool. You'll notice that there is a green and a red arrow, okay? This green arrow is pointing up, and the red arrow is pointing to the right. Now this is basically allowing us to move it along the two axes. Now, since we are working in a 2D game here, in 2D space, we have an X and a Y axis. Think of like a graph, okay? You have X that goes horizontally and Y which goes vertically. And we can pinpoint a number on the X and on the Y to specify a specific position on that graph, or in our case, in our 2D game space. So if I click and drag on this red arrow right here, you can see I can move our object left and right. And if I click and drag on the green one, I can move it up and down. Now, what you'll also notice is that with our player selected, if you look down here in the properties pane, you'll notice that our position property, which has an X, a Y, and a Z, has now changed. Okay, the X is set to 10 and the Y is set to 10. Now, you may be wondering what Z is used for. Z is really only used for 3D games, okay, adding in a third dimension to our 2D game here, but we don't need to worry about that for now. We can also manually go ahead and set our position. So if I set the X here to be negative 15, for example, and press enter, it's going to move us over to negative 15 here on the Z, or on the X, I mean. And we can then, of course, do the exact same thing for Y too. Now, you'll also notice on our move tool here, we have this little blue square at the top right corner. And this right here basically allows us to click and drag and move it anywhere we wish, okay? Which is also pretty nice. Now, you may notice that, if we move our thing over here, it's kind of hard to click on again. So what can we do to move our, not our camera around, but move our view around? Well, we can do two things. First of all, we could just press F to focus in on the selected object with the F key, or we could use the scroll wheel to zoom in and out. We can also then hold down middle mouse, and that gives us the ability to pan our view around our 2D game space right here. So yeah, as you can see, when I move my object around, that will change its position here in the properties pane. And this center point where the green and the red line intersect is going to be the 0, 0 point. So if I move it back to the center here, you'll see that my position is now 0, 0. If I move it to the top right, it's going to be about 43, 38. And if I move it to the bottom left, it's going to dip into the negatives at negative 46 and negative 30, okay? So that is how we can move our object around using the move tool. And we can also go ahead and, like I said before, manually enter in a property value for our X and for our Y, okay? Like so. Now, the next thing we're going to do is looking at the rotate tool, okay? Now, the rotate tool is going to allow us to rotate our object around. Now, to go to this, we can go to the top right corner of our editor and click on this rotate icon, or with the keyboard shortcut of E to go to the rotate tool. And what we can then do here is, you first of all notice that it looks very similar to the move tool. We have the X and the Y sort of color lines here, but what will happen is if we click and drag on those, something very strange happens, and that is because, just like with position, we can rotate in 3 different axes as well, okay? We have our pitch, yaw, and roll, okay? Our X, Y, and Z rotations. But in 2D, we really only want to be focusing on the Z rotation, okay? Because that is what we can actually see in 2D. So you'll see there is a circle that goes around the outside of our rotation tool. If we click and drag on that, that is going to allow us to rotate along the Z axis, which you can see is being adjusted right here. Now with this, we can also go ahead and manually give it a value. So for example, if we enter in 90, which is 90 degrees, that will make our player basically 90 degrees facing adjacent to where it was before. And yeah, that is the rotate tool. Now, once again, rotating along the X and Y axes isn't necessarily something you probably want to be doing in 2D, just because it does warp the perspective a bit of our sprite. So I recommend just sticking to rotating along the Z axis right here, as that is really what works best in 2D. And finally, we have the scale tool. Now the scale tool, if we go to the top right corner here, we can click on it like so, or use the keyboard shortcut of R to go to the scale tool. Now the scale tool, just like with the move tool, we have the little green and red dots here that we can click and drag on to scale along the X-axis and scale along the Y-axis. And you can see its change happen down here in the properties window. We can also uniformly scale our object up by clicking and dragging on the central blue square right here, which is going to scale up all axes uniformly. Now, scale is not in terms of pixels or degrees, but rather it is in terms of, I guess you could say, times, okay? Because right now, our object is 1 times its original scale. If we enter in 2 for the X and Y, our object is now 2 times its original size, okay? So that's how the scaling properties work. You can sort of think of it as times. Whereas if I enter in 0.5 for these 2 axes, our object is now going to be half its original size. Alright, so as a bit of a challenge, this is what I want you to do. I want you to go ahead and copy and paste our player game object a couple times, and you can do this by selecting the game object, going Control-C, then Control-V, as you would with anything else on your computer, to copy and paste it. And I want you to then orientate, scale, and position them like so, okay? So have a go at this, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Pretty much what we're going to do is we are going to get our player game object. We're going to go Control-C to copy it, and then Control-V to paste it. And you can see it is going to create a brand new player object here. And it's also going to automatically give it the name of Player 1 to differentiate it from the last one. Then what we can do is we can drag this up, and we then want to rotate it 180 degrees along the Z axis. Now we could go to our rotate tool and do that manually, but I'm just going to go into our properties panel, go down to rotation, and set the Z to be 180. And there we go. And we also want to shrink it down in size a little bit as well. So we're going to select our player, press R to go to the scale tool, and then we can scale it down about so, and then move it down here. Now let's copy and paste our player again. And this time we're going to rotate it 90 degrees. So we'll go rotate 90 on the Z. We can then move it up about here, and then let's increase its scale a bit as well. There we go. And then finally, copy and paste this big one, move it over here. I'm going to set the rotation on the Z to be -90, which is going to allow it to face to the right, and there we go. So you can see how we can use the rotate, scale, and position tools to pretty much design our level and our layouts exactly how we want them to be. So you'll be using these tools all throughout your journey with Defold, as they are a core part of the engine. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at how we can set up input actions. Now inputs are basically, well, as they sound, inputs, okay? We can press keys on our keyboard to trigger certain actions that we can then listen to inside of our code. So for example, we might have a jump action that gets triggered when we press the spacebar, and we can then listen to that jump action inside of our code and then make the player jump when that action is triggered. So how can we set these up? Well, what we're going to do is we are going to go over to our assets pane here at the top left, and we are going to go down to the input folder, and inside of the input folder you should see a game.input_binding file. We're going to double click on that. And this is going to open up our input bindings right here. Now, there are a number of different triggers that we can set up. We can set it up for keys for our keyboard, mouse, gamepad, touch, and text. We're mainly going to be looking at key triggers, although you can set up mouse triggers and gamepad triggers if you wish. Now, for key triggers, this is basically when keys on our keyboard are being pressed. So let's set up 4 new input actions, and these are going to be for moving up, down, left, and right, okay? And we're going to do that with the arrow keys. So to begin, we're going to click on the plus right here, and that's going to create a brand new action. Now, we have two things we need to fill out, and that is the input and the action. Now, the input is going to be the exact key that we need to press, and the action is going to be the name of that input, or the name of the action that we are then going to listen for inside of our script. So I'm going to double click on the action property here, and I'm going to call this move_up. Now what we can do is assign an input to it. So we're going to double click on where it says space, and we can click on the down arrow, and then let's scroll until we find the up arrow key. Okay, here it is, up. We'll click on that. So now our move up action is going to be triggered when the up arrow key is pressed. We can do the exact same thing for move down. So we'll create another one here, move down, and this one is going to be our left, or our down arrow actually. So let's scroll down until we find our down right here, and there we go. Now, as a bit of a challenge, I want you to go ahead and create two more actions for move left and move right. Okay, so I hope you had a go at that challenge. Pretty much what we're going to do is we're going to create a new key trigger right here. We're going to name it move_left, and the input is going to be our left arrow key. So we're going to scroll down and find left. There it is right here. We can then create another one for move right, and this one is, as you can guess, is going to be with the right arrow key. So we're going to scroll down and find right. There it is, and we are now done. So that is how we can set up input bindings for our game, and you can create as many as you wish here, and you can create some for the gamepad as well, which is basically controllers for your mouse, for touch inputs as well. Now, what are we going to be using these for? Well, we are going to basically be using these inputs so that we can move our player here left, right, up, and down with the keyboard, okay? We're going to make a little game later on for the, to utilize those things. But first, we need to actually learn about scripting and how we can actually begin coding inside of the Defold engine. So that is what we're going to be looking at in the next lesson. And I'll see you all then. Hey everyone, in this lesson we are going to be looking at an introduction to scripting. Now scripting is a very important aspect of the Defold engine, as this is where we give our game logic. So first of all, what is a script? Well, a script is basically a file which can contain code that the game can then run, okay? So if you've ever seen all those lines of code, that is basically what we are going to be doing. We'll be stuffing all of that into a file, which is known as a script, and a script can then be attached to a game object via a script component, okay? This is a component we can add similar to a sprite or a collider, and we can assign that script file to that component to then run that code for that game object. Now, it's also important to note that there are many different scripting languages, many different programming languages out there, and Defold uses the Lua language. Now, the Lua language is very good because it's a very readable language. It doesn't have a lot of complex and, boilerplate bits and pieces that you need to add to it. It's fairly straightforward and to the point, which is very great if you're learning to code. So, let's hop over into Defold right now and have a look at how we can start by creating our first script. Alright, so to create a script, what we're going to do is we are going to go to our assets pane right here, and I'm going to create a folder for our scripts. So I'm going to go to our main folder right here. I'm going to right click on it. I'm going to go new folder, and I'm going to call this scripts. Now, you can store these scripts wherever you wish, but I just like keeping things a bit tidy in our project so everything's not all over the place. Okay, we can then right click on scripts, go down to new, and what we want to find is script. Now, there are a number of different types of scripts. We have script, render script, and GUI script, which is for UI. We just want to create ourselves a normal logic script, which is going to allow us to add in mechanics, behaviors, and all sorts of things for our game. So we'll click on script. Let's call this one our player, and then we'll click create script. And there we go. Now, two things are going to happen. We're going to create the script right here, and you can tell it's a script by having the little icon, this little yellow gear icon, as well as the .script extension, and it's going to open up that file into the script editor right here in the editor pane. And this is basically a text editor where we can start entering in text, or more specifically, entering in our code. Now, we're not going to look at this just yet. First of all, let's hop over back to our main collection and attach this script to our player game object. So, what we're going to do is, if you haven't already created a game object for player here, you can go ahead and do that right now. Just right click on collection, add game object, and then attach a sprite component to that. Now, to attach the player script to this, you may be thinking, okay, I just right click on the player game object, go add component, and go down to script, but there is no script component to add here. And the reason why is because we need to instead go down to add component file. And this is basically going to add a file as a component, which is going to be our player script right here. So we'll select that and click OK. And now you can see here we have our player script attached as a component to our player. So now any sort of behavior that we write down in code, it will be assigned and applied to our player game object, okay? That's very important to know. A script generally is only going to manage whatever game object it is attached to, unless of course you have a script which is designed as a management script, managing other things, but most of the time a script is going to only really know that its game object exists, and it is going to be applying logic and mechanics to that game object. So if you were to have, for example, a coin script that you attach to a coin, that coin script is really only going to manage, maybe moving the coin up and down, spinning it around, and detecting when something has hit it to increase the score. Okay, scripts generally are going to be as self-contained as possible. You don't really want to add all these dependencies, trying to attach itself to other things, manage other things, that can get quite convoluted. And yeah, once again, scripts generally should be fairly self-contained and managing only what they need to manage for that object. So let's now go over into our player script right here. And you'll see, first of all, a lot of code, okay? There's quite a lot of code right here already set up for us. And if you do want to zoom in or out, you can simply hold down Control and use the plus and minus keys to zoom out and plus to zoom in. Okay, I'm going to zoom in a little bit here so we can see it nicely. And in the next lesson, we are going to be going over what this stuff here actually is. Because right now, there's a lot of things. We have function update, lots of text on screen. So we're going to have an understanding of what all of this does before we actually begin learning to code. So I'll see you all then in the next lesson. Alright, welcome back everyone. In this lesson, we are going to go through a lot of these preset code that is assigned to our script upon creating it, okay? As you can see, there's around 50 lines of code that is added here, and we need to understand what this is doing, okay? Why is this here by default when we create our script? Well, first of all, it's important to know that if you wish, you could simply select everything and delete it and begin from scratch, okay? There is nothing that is necessarily required in your script. This is just here, I guess, as a bit of a starter point, okay, to give you a little bit of a tutorial. As you can see, there's a lot of text here with learn more resources that you can follow if you wish to learn more about them. Okay, now what we see here with all of these different functions, as you can see, it says function update, function final, function init, function fixed update. These are all what are known as functions. Now, we're going to get into what a function is a bit later on, but basically, just think of a function as a block of code that can be executed whenever we wish, okay? So for example, at the start of the game, we might want to call a function that runs specific things. We might also want to have a function that runs every single frame to basically update our player's position, perhaps if we're moving around. These are all functions that each serve a specific purpose. Now, we can of course create our own custom functions to do whatever we wish, such as maybe adding score, taking damage, but Defold also has a large number of preset functions that have predefined conditions for them being called, okay? And these are known as callback functions, because basically these get called when something happens. Now, you see here we have a function called init, final, update, fixed update, and so on and so forth. Now, these are all functions that are built into the engine itself, and Defold calls these automatically, so we don't need to worry about calling init, calling final, calling update. These functions get called when certain things happen, and we can then write code to execute when those things happen. So let's go through what each of these functions do so that we can have a better understanding of how this engine might actually work. So init right here. This gets called when the component is initialized, okay, and meaning the script component. So when our when our game starts and the game is loading in all of our collections and game objects, okay, when our collection here is loaded in and our player gets loaded in, it then loads in its sprite component, it then loads in its script component, and when that script component is loaded in for the first time, this init function gets called. So if there is any code that you want to set up right at the start of the game, you would put it inside of here. Now, final is basically the opposite, okay? This gets called when the component is deleted, okay? So if, for example, we might have a bullet game object that is flying across a screen with a script attached to it, it hits something, it gets destroyed, this final function would then be called at the frame it gets destroyed on. And also, this gets called at the end of the game, okay? So, for example, if we close down our game, this final function will also be called. Now, down here in update, this is a very handy function because this gets called every single frame, okay? So if our game is running at 60 FPS, this function is going to be called 60 times per second. And this is very handy if we want to check things or move our player over time, we can use the update function. Now, alternatively, we also have this function down here called fixed update. Now, fixed update is very similar to update, but it works on a very different basis, okay? Fixed update is generally where you want to run physics simulations, and the reason why is because it runs on a fixed update frequency. And that basically means that it does not run every single frame, but rather it runs a set number of times per second. So for example, if we set our fixed update frequency to be 50, this means that this function, no matter what, is going to run 50 times per second, whereas our update function is going to run every single frame, no matter how fast or slow it is. So if our game is running at 500 frames a second, update is going to be called 500 times per second. If our game is lagging and we're running at about 20 frames a second, update is going to run 20 times a second. Whereas fixed update, no matter if our frame rate is down at 30 or up at 1000, it is always going to run a fixed number of times per second. And that is because physics likes consistency, and especially if you're doing stuff over time with physics or moving your player around, generally it's best practice to do it here inside of fixed update. Now, down here, we have our next function, which is very important, and that is the onMessage function. Now, when it comes to Defold, messages is basically a core principle of the engine itself. This allows us to basically send off a message and listen for it and then do something based on that message. And this onMessage function is basically the receiver, okay? So it listens for specific messages. We can listen for a message and then we can go, okay, is the message we got, is this to increase our score? If so, increase the score. Is this a damage message? If so, then damage ourselves. Is this a message that wants us to activate the camera, or is it a message that wants us to allow inputs? If so, then we are going to do that. Okay, there's a lot that goes on with this function. We will be going back to this later on, but for now, just know that this basically receives messages and we can then do stuff based on that. The next one down is onInput. Now, the onInput function, this here basically listens for our inputs, okay? So if we have our input actions for move up, down, left, and right, this is where we are going to be listening for those and then doing stuff based on if they are being pressed or not. And then finally, we have the onReload function. We don't really need to be worrying about this. This has to do with the engine's hot reloading functionality, running code based on when that happens. 99% of the time, you're not going to be using this, and especially if we're learning at the beginning, we really do not need to worry about onReload, as this is more of an advanced feature, I guess you could say, with the engine itself. So we don't need to worry about this. But all of these other functions here, we will be going back to them. We will be looking at them in a bit more detail. So do keep them in mind when we are creating our game and learning scripting from here on. Now, let's actually go ahead and see these in action. Now, before we can actually test these functions out, we first of all need to know how we can actually play our game. So, to play our game, what we're going to do is go up to where we have project and click on build. Okay, it's simple as that. And as you can see, here it is. Now, you will notice that our player is very small, and that is because our player is being rendered in terms of pixels, so that is why they are pretty tiny here in the corner. We can also use the keyboard shortcut of Control B to play our game as well. That will launch the window here. Now, if your player is, maybe in the corner or not really visible on screen, that might be because your player is not inside of the view. Now, to change this, we're going to select our player game object and make sure that they are in the top right corner of this. So make sure that on the right hand side of the green line and up above the red line, so in the positive, we'll put them about there. Go Control B and then you'll see that our player is right here. Okay, and in the next lesson, we are going to be testing out the init function, the final function, update, and fixed update to see if they actually work and see how often and when they get called. So thanks for watching, and I'll see you all then. Okay, now let's look at actually making these functions do something. So what we're going to do is we are basically going to print out to the console down here. Okay, the console here, we can click and drag to drag it up. We can basically print messages to the console to check to see if certain bits of our code are working as they should. Now, you may be thinking, okay, what is all this code that is already added to each of these functions? Well, basically, this is not code, but rather a comment. Now, you can tell it's a comment by the fact that the line is gray and has the 2 dashes before it. Now, a comment is basically like a note, okay? We aren't actually executing this code when the script is run, but rather it is only there as sort of just a comment or a message for us humans to see, okay? The computer, when it executes and compiles this code, it does not read it, okay? It just skips right over it. So what we can do is inside of the init function here, we can select these 3 lines of code and delete them. Now, inside of here, what is known as the function body, okay? Everything between the function declaration and the end keyword right here is going to be inside of the init function, and this is going to be called once when the script component is initialized. Now, what we're going to do inside of here is we are going to enter in this. We're going to go print, and then inside of 2 parentheses, we are going to add in 2 quotation marks and enter in some text. So we might say start, or we'll enter in just the word init. Now, what we are doing here is creating what's known as the print function, and this right here is what allows us to print messages to our console down here. So now if I go ahead and play the game, what you'll notice is that down here inside of our console, you'll see we have a little blue thing here which says debug script, and it says init. Okay, so this basically means that we have printed the init message to our console down here when our game is started for the first time. Now, we can make this message whatever we want. We can make it say hello, we can test that out again, and there we go. You can see down here it says hello. Now, I'm going to replace this with init for here. And then down here inside of final, this gets called at the end of the game, or when the script component is destroyed. We can go here and print out final, like so. Now, the way that you write this and lay it out is very important, okay? We have our function declaration right here, and then everything that is inside of the function must be 1 indent space in front, okay? Now, generally, when you go to a new line, it's going to have that indent automatically, but if there isn't, then you can simply press tab on your keyboard to indent once, and then you can continue writing. Now, with this print function, it also needs to be written out correctly. So that is lowercase print, an opening bracket, then what is known as a string or a bit of text inside of quotation marks. You can tell it's a string by the yellow text formatting, and then finally a closing parentheses here. And this is the print function layout, okay? So now if we press play, what you'll notice is that we have the init message here, which is what we should expect. And then when we exit out of the game, we have final. So then final gets called. Now down here in update, this gets called every single frame. So let's go ahead and delete the comment and add in a print function here, which just says update. Okay, and let's see how many times this gets called. So I'm going to play the game. And as you can see here, we have init, update, and then update again, but it's not called, but you can see it's not really being called again, and that is because if we look to the left here, you can see that we have this number which is going up, okay? It's got plus 900, every single frame it is ticking up, so we are getting hundreds and hundreds of these pretty much every couple seconds, okay? You can see they're stacking up here on the left-hand side quite a bit. So update is working, that is being called every frame. We can also then have fixed update, so if we go down here, delete these comments, print out fixed update. Okay, save that, press play. You can see that we are getting all of these messages here. Now, all of a sudden, they are becoming stilted like this just because we are calling them one after the other. If you do have repeated messages being called in a row, then they will be sort of stacked or collapsed in on themselves. Whereas if we have them staggered like this, they are being called one after the other. So you can see here, in fact, how often fixed update runs compared to update. Okay, so for us, every 3 to 2 update messages is when a fixed update gets called. So you can see that update is being called every frame, but fixed update is being called every, maybe I guess around 50 or 60 times per second. And we can of course change this in our project settings. And then we have on message, which we can't really print anything in here because it's sort of a receiving function that receives messages from other sources. So we will be looking at this a bit later on. But for now, let's just go ahead and clean up our function. So I'm just going to delete all of the comments from them, like so, just so that we have nice clean functions here. On update as well, or on input I mean, we can also make that empty. And on reload, we are just going to go ahead and delete this function since we're not actually going to be needing it in our course here. So I'm just going to delete that function there. And now this is what we have. We have our init function, final, update, fixed update, on message, and on input. Now, in the next lesson, we are going to begin looking at what's known as variables. And variables are very important because they are basically the building blocks, the foundations of coding, okay? So in the next lesson, we'll be looking at variables and how we can use them. Hey everyone, in this lesson, we are going to be looking at variables inside of Defold. Now, what is a variable? Well, basically, a variable is a piece of data which can be assigned, modified, and read. Okay, this is basically just a bit of memory that we can give a value to and take a value from. Okay, so things such as your player name, your speed, your score, the amount of damage you want to deal, the amount of maybe pickups you have, how high you can jump. Those are all things that we might store as variables. Now, a variable can store a large number of different types of things, such as numbers, text, references to other components and other collections, other game objects, etc. There are many different types of things variables can store that we will be looking at. Now, how do we actually go about creating a variable? Well, it's done like this. We write down the keyword self, which is basically a reference to the current component that the script is attached to. Then we go dot, we give our variable a name, so we might want to call it score, we might want to call it damage, and then we give an equal sign and then a value to assign to that variable. Now let's have a look at how we can do this inside of our script. Okay, so here we are inside of our script. Now I'm going to go up to the init function right here, and I'm going to start by creating a variable, okay? So let's go self, then dot, and we're going to give this variable a name. So let's just go score and then go equal, and we'll give it a score of 1. And there we go. We have now gone ahead and created ourselves a variable. So now what we can do is just go to a new line here, and let's print it out to see if it works. So we're going to go print, and then instead of going quotation marks, score, we are instead just going to enter in the self.score variable, okay? Because what we are doing here on the first line is we are assigning the variable, so we're going score equals 1. Okay, so score is now equal to 1, and then in order to access this variable, if we want to read it, okay, we can go self.score, and that will retrieve us the variable. And what we are doing here is we are basically just printing out the value of that score to the console. So now if you press play, if we build our game with Control B, you can see here we are now printing out the letter 1. Now what we can do is we can maybe change this to maybe make it a big number, maybe something such as 5,000. Okay, build that again, and then we go 5,000. Now, what's great about setting variables like this is that we can actually go ahead and reference these variables in other functions, okay? So if we go down to final, we can then print out the score again, something like this. Oh, we need self.score. There we go, print self.score. So now if we play that, there we go, 5,000. And if I close the game, we get 5,000 printed out again. Because when we go self.score, we are creating a variable called score, and that is basically attaching it to our script component right here. So this script component is basically having that score variable inside of it, and it can then read it, it can write to it whenever it wants. Now, there are many different types of variables that we can set up, so I'm going to go ahead and just delete the one in final here for now. What we have right here is a number, so we can have a whole number, which is known as an integer, or we can have a decimal number, which is known as a floating point number. And to do that, we just add a decimal and then just go something like .26. So now our score is 5,000.26. It just gives us a bit more precision. We can also have what is known as booleans, and booleans are basically variables that can be true or false. So let's create a new variable here. We're going to call this one self dot, we'll call this one game over, so game underscore over equals false. Now if we print self dot game over and we build that, you'll see we have false printed out here. Now false, the opposite of that is true, and this is really good if you want to keep track of sort of a binary state in your game, such as game over. Maybe you want to check to see if the player is alive or not. You could have that as a Boolean variable, which is true or false. We can also store other things inside of variables such as text. So for example, you might want to have a variable called something maybe such as player name, so self.playerName equals, and then to have text, we don't just write it down, so we don't just write out a name such as Bob. Instead, we need to put this inside of quotation marks, okay? And you can tell if something is a string because it is going to be yellow, okay, with these double quotation marks on either side. And then we can print out self.playerName, like so, build that, and then down here we have our player name printed out. So that is a look at just a couple of different variables right there. Okay, so as a bit of a challenge, I want you to go ahead and create these 4 variables right here, okay? And these are just comments, so this is just me listing them out here for you to see. I want you to create a variable which is called health. I want you to create a variable which is called item name, jump height, and falling. And I want you to assign appropriate values to those, okay, using the correct types of variables, okay? Remember, we have integers, which are whole numbers, floats, which have a decimal point, strings, which are text, and then booleans, which are true or false. And I want you to go ahead and create these 4 variables and assign a value to each of those, which you think would be, you know, the proper sort of value that you would assign, okay? So if that is a string, integer, float, or boolean, and then print them out. Now, I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. So first of all, with our health variable, we are going to create that variable. So we're going to go self.health, and then we are going to make this a whole number, okay? So we'll just make it 100. And then we can print it out by going print self.health. And if I build it, we should see in the console, it gets printed out just nicely. Now, next, item name. For this, we're going to use a string for the item name. So I'll go self.item_name equals, and then we'll just say something such as sword, okay? And then we can print that out, self.item_name. The next one is going to be jump height, and this I think is going to be a float because jump height, you might not want to be a whole number, you might want to be very precise about it. So I am going to go self.jump_height equals, and then we'll say something maybe such as, we'll go 80.5, okay, a nice precise number, and then print that out. And there we go, whoops, there we go. And then finally, falling, which is going to be true or false, whether or not the player is currently falling. This is going to be self.falling equals false. And then we can print that out like so. So there we go. Those are our 4 variables that we've created and defined right here. Now, if I go ahead and play this, you'll see that all of those get printed out in order. Now, that's something very important that you also need to keep in mind is the order of execution, okay? So when this init function is called, it is going to go line by line, okay? So we're going to call line, this one, then this one, then this one, and so on and so forth, okay? But so it's important to know that. So if you are doing stuff such as maths and calculations, make sure that you're doing it in order, okay? You're doing the stuff that you want to do first at the top of the function and stuff that you want to happen at the end down at the bottom of the function, okay? Because you can't really jump between different points in the function. It really only goes down the line, okay? So that is why every time we play our game, it is going to be calling these 4 print commands in the exact same order. And something else you may also notice is the way that I'm writing out these variables, okay? For item name, for example, you may be wondering, why am I not adding in a space? Well, that is because spaces don't really work that well when it comes to variable names, okay? Spaces are a very important and specific thing in programming. So when we have our item name variable here, for example, it is going to think we want to create a variable called item, and then we have this weird name text in the way, so it's going to return an error, okay? If I press play, you'll see we have an error here, compilation failed. You see we have all this problem. So we need to stick this together, okay? You cannot have no spaces in your variable names. Now, in Lua, it uses generally what's known as snake case. And snake case is basically where we have everything in lowercase letters, and instead of a space, we instead put an underscore, okay? So you'll see here for item name, I have item underscore name, jump height, jump underscore height, and everything else is in lowercase letters. You'll see here with our functions, everything is lowercase. There's no real uppercase letters. And that is just the general practice when it comes to the Lua language in Defold. And down here with fixed update, you can see we have the underscore again, same with on message, same with on input. So this is just a general thing that is present across the entire engine. And generally when you're jumping between different coding languages and different engines, you generally want to stick with the best practices and the coding style that they are using, as when we are interacting with different parts of the engine, we want to, of course, be coding those in the same way that we would everything else. So sticking with snake case throughout our scripts is generally going to be the best way of going about it. You can, of course, name your variables whatever you want. Instead of, we can create a new variable down here. For example, we could go self dot, we could then go player health in all capitals and make that 1. Print that out, self dot player health. Okay, so you can see we can really call these variables whatever we wish. And you can see that does get printed out just fine. But like I said, we generally want to stick to snake case, not because we have to, but because it is the best practice, okay? So yeah, you can, of course, if you want to, choose to call your variables in whatever format you want. You might want to just call it player case, player health like this in what's known as camel case. But yeah, generally, we're going to stick to snake case. Everything lowercase and everything that would have a space is instead going to have an underscore. Hey everyone, in this lesson we are going to be looking at operators. Now what is an operator? Well, basically an operator is a symbol or a keyword which can perform mathematical comparison or logical operations. Now the theory behind it, it gets quite wordy, but in practice, in this lesson specifically, we are going to be looking at how we can perform maths with our code, okay? And these are known as arithmetic operators, okay? So we have things like addition, subtraction, multiplication, and division. And each of those have a specific symbol that we can use in order to define if we want to add two numbers together, subtract them, multiply them, or divide them. So addition, we have the plus symbol. Subtraction, we have the dash symbol or the minus symbol. Multiplication, we have the asterisk. And division, we have the /. Now let's hop over into Defold and have a look at how we can set this up. So here in our script, what we're going to do is up inside of our init function, which gets called at the start of the game when our script component is initialized, we're going to start off by creating ourselves a variable. So let's just say we want a variable called, we'll call this one score, for example, or just a nice variable name. And we're going to equal this to, let's just say we want this equal to 10 plus 5. Now, when we print this out, okay, when we print out self.score, what do you think the result is going to be? Well, let's see what it is. So I'll build our game, and you can see it prints out the number 15. And that is because our score is not being equal to 10, but rather it is being equal to the sum of this right here, which is 10 plus 5, okay, 15. Now, we can also do subtraction, so we can go score equals 10 minus 5, which is going to give us a score of 5. We can also do multiplication with the asterisk, which is going to give us 50. And we can then do division as well, which is going to give us 2, okay? Now, as well as this, we can maybe go score equals 10. Now, on a new line, how would we go about actually increasing the score by 5? So first of all, let's actually print out our score. So we're defining the score as 10. We are printing it out. Then what we want to do is increase the score by a certain amount or change the value in some way and then print it out again. Well, to change the value of score, we simply just get the reference of score, so self.score, and then we give it a new number. So maybe something such as 20, and then print out self.score. So now you'll notice that we have 10 and then 20 printing out in the console, and that is because we go line by line. So our first line here, we are setting the score variable to equal 10. We are then printing it out, which is 10. We are then setting our score variable to be 20, printing it out, 20, okay? But let's just say instead of wanting to just hard set it to a new number, we instead want to increase it by, for example, 2. So how would we do that? Well, what we would do is we would go self.score equals self.score plus 2. And this right here is basically setting our score to be its current score plus 2. So now when we print this out, you'll see it prints out 10, then 12. Okay, we are increasing our score by 2. Now we can also do the exact same thing with subtraction. So we can subtract 2 from our current score, which is going to give us 8. And then we can of course use the asterisk for multiplication and the / for division. Now, what's great about these operators is that we're not just limited to using one operator at a time, okay? If we want to create a mathematical formula here, for example, we can stack as many operators as we want. So for example, we could go self.score equals self.score minus 2, then maybe multiplied by 3, divide that by 0.5, and then add on another 5. So you can see we can sort of stack these up, and if I press play, I actually have no idea what this is going to equal, but if we press play, you can see our computer is going to calculate that for us, and it equals 3, okay? So you can see how we can sort of stack all these operators up next to each other and use them in whatever way we wish. Okay, so I have a bit of a challenge for you. As you can see here, I have defined a variable called health and have set it to be equal to 100. Now what I want you to do is I want you to start off by subtracting 35, adding 4, dividing it by 3, and then multiplying it by 5, and then finally print off the result at the end to see what number you get. So have a go at that, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Let's continue on with the answer. So what we're going to do is we're going to start by getting our health variable and adding or subtracting 35. So health equals self.health minus 35. We then want to add 4, so we'll go self.health equals self.health plus 4. We then want to divide it by 3, self.health equals self.health divided by 3, so /3, and then self.health equals self.health multiplied by 5.5, so asterisk 5.5. And then finally, print off the result and see what number we get. And when you press play, you should get 126.5. Hey everyone, in this lesson, we are going to be looking at if statements inside of Defold with the Lua language. So what is an if statement? Well, basically, an if statement runs code only if the given condition is true. Okay, this is where we start implementing what's known as flow control. Because right now, every bit of our code that we write inside of a function is being executed. But with if statements, this allows us to decide, okay, maybe this bit of code runs only if this certain condition is true. And a condition is there basically to evaluate whether a given statement is true or false. So is this number greater than this number? Is this variable equal to this specific number? Is game over true? Stuff like that. Now, how does this work? How do we define an if statement? Well, we do it like this, okay? In the example, I've created a little variable, which you don't have to do, but, just to show that we have a variable there. But basically, an if statement is defined by, first of all, writing down the keyword if, then a space, and then you enter in your condition. In this case, it is checking to see if A is equal to 10. Now, you can see we have two equal signs here. This is what's known as the comparison operator, okay? A single equals is assignment, meaning that we are assigning a number with equals. Double equals means we are comparing. We are checking to see if whatever is on the left is equal to whatever is on the right. And if that is the case, then that will be true. Otherwise, it will be false. Then we have the then keyword, a new line, which is where we enter in the body of our if statement. So if that condition is true, then whatever code is between that and the end keyword at the bottom will be run, very similar to how a function is defined. Okay, a bit of a cleaner example is like this. We have if, condition, then, the code to run, and then at the end we have end, okay? So make sure that between then and end, everything between then and end is going to be the code that is run only if the given condition is true. Now, let's look a bit more of these conditions, okay? How do we create a condition and what different things can we define them as? Well, these conditions use what are known as comparison operators. We've already looked at arithmetic operators, which are like plus, minus, subtraction, stuff like that. But comparison operators compares two values on the left and then on the right, and it checks to see if that statement is true. So, for example, we have less than, greater than, less or equal, greater or equal, equal or not equal. So, for example, with the less than, we would have, for example, a number such as 5 and then the less than symbol and then a number such as 10. So if 5 is less than 10, that will be true, which it is. Otherwise, it will be false, okay? And then we can plug that into our if statement to basically check to see if a given condition is true or false. If it is true, then we run that code. Now, let's hop over into Defold and have a look at how we can actually start creating these. Okay, so up here inside of our init function, what we're going to do is start off by defining a variable. So let's just say we'll give this variable a name. We'll make it nice and simple. We'll just call it a, okay? So this could be anything, and we'll give it a number such as maybe 15. Now, let's go ahead and write some code to print out a message only if a is equal to 15. So if a is equal to 15, then we print this message. Any other number, and that's not going to happen. So to do this, we write down if, and then we go space, and then we need to define a condition. So the condition is going to be if a is equal to 15. So to do this, we can go self.a equals 15. Then we enter in the then keyword, okay? And then on a new line, we can enter in our code. So we can go print a is equal to 15. And then at the end, we need to make sure to end it off with the end keyword like so. Now, if I build this, you'll see down here in the console that we indeed have a is equal to 15 being printed out. But what happens if I go ahead and change a into, instead of being 15, I change it to be 33? Well, now if I press play and build this game, you can see that we get no such message. And that is because the code in between this if statement is only being run if the given condition here is true. Now, what if I replace the equal sign with a greater than sign? Okay, so if a is greater than 15, then we can say a is greater than 15 right here. Is it going to print? Is it not? Well, let's see. We build this, and it indeed says a is greater than 15 because a is 33. 33 is greater than 15, so the condition is true, so it will print. And yeah, that is basically a look at operators, okay? There are many other things that we are going to go over in future lessons to do with operators, but for now, this is the basic, okay? Let's go ahead and create another variable. We'll go self.b, and we'll make this number maybe 100. And so instead of having a strictly typed number here, a static number, we can instead add in another variable, self.b. And let's see if these two numbers are not equal to one another. So we'll add in the tilde equals sign to add in the not equal operator here. So if a and b are not equal to each other, then this will print. So here we can go a is not equal to b. Okay, what do you think it's going to happen? Is it going to print? Is it not? Well, if we build this, it is indeed going to print because a is 33, b is 100. These two are not equal to one another, so this condition is going to be true. Whereas if we make these equal, so if we set b to be 33 and build it, it's not going to print because these two are equal and we are checking to see if they are not equal to one another. Okay, so I have a bit of a challenge that I want you to complete. This is going to sort of simulate a bit of a gameplay loop, not necessarily, but it's going to simulate a little chunk of gameplay. Basically what I want you to do is I want you to start by defining a health variable, so a variable called health, set its value to be 10. Then I want you to subtract 15 from it on a new line. Then I want you to create an if statement, and this if statement is going to have a condition that is going to check to see if the health is less than or equal to 0. If that is the case, print out player has been defeated. Okay, so have a go at that, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Let's have a look at how we can complete it. So first of all, we need to define a health variable. So we're going to go self.health, and then we need to set it to be 10. So we'll go equals 10. Next, we need to subtract 15 from it. So we'll go self.health equals self.health minus 15. Now that's going to bring us to around -5. We then want to create an if statement. So we'll go if, and this is going to have a condition that is going to check to see if the player's health is less than or equal to 0. So we'll go if self.health is less than or equals to 0, then we are going to print player has been defeated. And then make sure to end it off with the end keyword like so. Okay, now let's see if this is going to run. So we can build it, and there we go. Player has been defeated. But what if we start off with a bit more health? Let's make our health 40, okay? And if we minus 15, that is going to bring us at around 25. So now if we build it, as you can see, the message does not print because our health is not less than or equal to 0. Hey everyone, in this lesson we are going to be expanding upon if statements by looking at what is known as else if and else statements, okay? These are sort of additions to our already understood if statement, so let's have a look at how these work. So an else if statement basically allows us to check another condition only if the first if statement returned false. Okay, remember an if statement checks a condition for whether or not it is true or false. If it is true, then the code it contains will be executed. Otherwise, if it is false, then it will basically not run that. And in the case of adding on an else if statement to the end of an if statement, that code will then be checked only if the first condition is false. So as you can see in this example here, we are basically checking to see if the day variable is equal to Monday. If so, it'll print out today is Monday. Otherwise, if it is not Monday, then it'll check to see if it's Thursday. And if so, it'll print out Tuesday. Okay, else if statements are very great, and there are many use cases which we will be looking at. Now, what's great about these is that we can stack as many else if statements as we wish. Okay, as you can see here, we can just go if, then else if, else if, else if, and you will keep going as pretty much far as you'd like, okay? But there's also another thing that we're going to learn about, and that is the else statement, okay? Basically, whatever code that you put inside of else is going to run if all the above connected if statements and else if statements are false, okay? So here we are basically checking to see if our score is equal to 100, and if so, we are setting our has1 variable to true. Otherwise, if that is not the case, then we are going to print need more score. So let's hop over into Defold now and have a look at how we can set this up. Okay, so let's start by creating a variable. So here we're just going to go self dot, and we'll call this one a, and we'll have this equal to, let's just say 50. Then what we can do is we can create an if statement. So here what we're going to do is we are going to go if self.a is greater than, let's just say 25. Then we can write the then keyword, go to new line, and print out a is greater than 25, and end that off with an end keyword here. Now, we can build this, and as you can see, we of course get the message down in the console, but if we change our variable to, let's just say 15, we are not going to get that, okay, because this condition is no longer going to be true, so this code is not going to run. Now, let's just say we want to check another condition only if this one here is not true. Well, we can add in the else if keyword here at the end. Okay, so here we can go else if, oops, make sure there is no space, and then we enter in our next condition. So we can go self.a, let's just say if it is less than 25, then we can print out a is less than 25, and then end it off with the end keyword. Now, if we build this, what do you think is going to happen? Well, we are going to have a is less than 25 printed out. Now, the reason why is because this first condition, it will check. If it is true, then it will execute this code here and not look at this, okay? The else if only ever gets checked if the above if statement is false, okay? So else if is only ever going to check its condition if the above is false. So if the first condition is false, we then go to the else if, and if that is true, we run the code. Otherwise, we just continue on. And we can also stack up as many else if statements as we wish, okay? It's probably not the best practice to stack up hundreds of them, as it can get quite convoluted and a bit messy, but you can do that. Now, we also have what is known as an else statement. So what we're going to do here is delete this example, and we're going to make up a basically simple scoring system, okay? The player is going to get 1, 2, or 3 stars based on a score. So we'll create a variable here called score, and let's just say this is going to be out of, we'll make it out of 100, okay? So what we're going to do is we're just going to make our score maybe equal to 50 for now, and then what we're going to do is we are basically going to score the player 1 to 3 stars based on their score. So here we're going to go, starting off by checking if the self.score, if this is greater than, let's just say, 77, then we are just going to be printing out, let's just say, 3 stars. So we'll just go asterisk, 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 like that. Then what we can do is else if self.score is greater than 33, then we can print out 2 stars. So print, and then 2 stars right here. Okay, and then finally, we don't need to do an else if score is greater than 0 because we can just then go else, okay? And then we can go print, and then we can just give them 1 star right here. And then make sure to end that off with the end keyword. Now, if we press play or if we build that, you can see we get 2 stars. Whereas if I go ahead and change our score to maybe something such as 99, we are going to get 3, okay? And that is because we are going through this if statement block right here. So first of all, we are checking our first if statement here. If our score is greater than 77, then this code is going to run, and the rest of these if statements and else statements are going to be skipped over because we no longer need them. Whereas if our score, for example, is 50, we're going to run the first condition. It's going to be false. So then we go to the else if. That's going to be true. So we run the code here, and then we skip over the else. Whereas if our score is maybe, let's just say 4, first condition is going to be false. Second condition is going to be false. And if all the above connected conditions are false, then else is going to run regardless. Hey everyone, in this lesson we are going to be looking at functions inside of Defold and the Lua language. So, what is a function? Well, basically a function is a self-contained block of code which can be called at any time to run, okay? And we've actually already worked with functions in the past. We've already been using the init function, which gets called once the script component is initialized for the first time. But we can also create our own custom functions, okay? We don't have to stick with the default ones that our Lua script gives us once it's created, okay? We can add as many new functions as we wish, and we can customize them in many different ways. So let's look at the structure of a function. We start off by entering in the function keyword. We then add in a function name. In this example here, print_num is the name of the function. Then in between 2 parentheses, we define our parameters. Now, parameters are basically like variables we can send over for the function to use, okay? In this case, we are sending over the variable self, which is a variable we have sent over in every single one of our functions. We'll get into what the self variable is in just a second. But we then go ahead and define the body of the function, which is basically all of the code that we want to run when the function is called, and then we finish it off with the end keyword, okay? Here's a bit more of a simplified view of exactly what we are doing here. So we have our function, our name, our parameters, and our code to run. Now, what is self? Okay, this self keyword we have seen pop up many times, okay, when we are defining variables, such here as self.num, and inside of our functions, we are sending over this self parameter. So what is self? Well, self is basically a variable which refers to an instance of that script component, okay? So let's just say we have a number of different enemies in our game, and they all have the same enemy script. Now, if, for example, we wanted to have each enemy have a different speed, okay, we want these enemies to move around all at different speeds. Well, if we were to create a variable and change that speed, typically that variable would be the same for every single instance of that enemy. But if we use the keyword self, okay, that means we are creating a variable on that specific given instance of the enemy, okay, or of that script component. And whenever we create a function, we want to send over the keyword self so that whatever code runs in that function gets applied to that specific instance of that script. Okay, we'll get into this a bit later on once we have more practical examples, but that is the basis of self. Now, another great thing about functions is that they can have both inputs and outputs, okay? They can take in values, such as parameters, and then output a result. So right now, we are only really taking in a reference to self, but we can do a lot more than that. In this example right here, I have a function called add, okay? And we have, of course, our self parameter, but we've also got two more parameters separated by commas, okay? A and B. Now, these are basically variables that we can then use inside of our function. And what we are doing here is we are creating a variable called sum, and that is equal to a plus b. And then we are using the keyword return to basically output that sum variable, okay? So you can think of functions as a factory. You have inputs, they get transformed, they get made, and then they output a final result. And to basically utilize this, we can, in our init function, create a variable called num and have this equal to that add function, sending over our self and our two numbers a and b. And then that num variable is going to be equal to the result of that addition. And then we can print it out, of course. Now, in this example here, you may see one thing that's standing out, and that is the fact that we are declaring our variables in a different way. Okay, typically we will declare them as self.num and self.sum, which is a viable option. Okay, that means those variables are tied to that instance of the script, which is great. But what we are doing here is we are creating what's known as a local variable. Basically, we are creating this variable local to its current scope. Now, what do I mean by that? Well, let's have a look at what this is. Okay, so local is another way we can define a variable. And when we define a variable as local, it basically means it only exists within the function or scope it is defined in. So with the init function here, we have two ways to create a variable. We have self.a, which creates a variable called a that's equal to 10. Now this a variable could then be referenced in other functions, okay? Let's just say we want to create a variable for our move speed, okay, or our velocity. Well, we could define that in the init function with a self.velocity or self.speed, and then in the update function, we could utilize that variable to move ourselves around. Now, we also have another way of creating a variable, which is by using the local keyword. Now, if we were to create a variable called b here, for example, in the init function and have that equal to 10, the difference is that if we were to go to the update function, that b variable would not exist, okay? And that is because when we define a variable as local inside of a function, it means that that variable is only ever going to exist inside of that function. Now, where might this be useful? Well, for example, if we are creating variables that don't really need to be known outside of a given function, we can define them as local. That just overall, I guess, saves memory in the grand scheme of things. Whereas defining a variable as self dot and then the variable, we are basically creating that variable and basically adding that to the instance of that script component. So we have access to it across multiple functions and across the entire lifetime of that component. Whereas again, local means we are only having access to that variable in the specific instance that we are running that function. Now, this is just general practice and best thing to do. So far throughout this course, we have been using the self method of creating variables, which generally you wouldn't want to do, but now that we are looking in functions and seeing how they work, I think it's going to be good to look at how we can define variables as local instead. So now let's hop over to our script and begin looking at how we can create some functions. Okay, so here we are inside of Defold. Now you'll notice here that we have all of these default functions that were sort of already created for us upon the script's creation, okay? We have init, final, update, and these all do specific things. Now we aren't manually calling these ourselves, okay? The engine behind the scenes is calling these functions for us. And you can see each of them have a self parameter, which is basically a reference to whatever instance of that script is calling the function. And you can see some other functions, such as update and fixed update, have multiple parameters, such as dt, which is delta time. We'll get into that in a bit. The onMessage function, you can see, has a large number of different parameters. It has a total of 4, which basically is sending over all the information required that you might need inside of here. So let's look at how we can create ourselves a function. So we're going to go to a new line outside of any other function, and we are going to start by creating the function keyword. We can then give our function a name. So let's just say we want this function to be called test, for example. We can then have an opening and closing parentheses, and inside of here, the one parameter we must send over is a reference to self. Otherwise, we are calling a function with no connection to our game world, essentially. Then what we can do is go to a new line, make sure it's indented, and here is where we can write all the code that we want to run. So here I can just print out the word test, and then make sure to end that off with the end keyword to define the end of the function. Now, we have our test function. If I build our game, nothing is going to happen. That's because we have created the function, but we haven't actually executed it, or we haven't actually called it yet. So how can we do that? Well, to call a function, we have already actually done this many times throughout the course already. This print line of code that we have been running is a function that we are calling, okay? We are calling the print function name, and we are sending over the parameter of test, which is a string. So we can call our own function up here in init, which gets called at the start of the game. Now to call a function, we just enter in the function name, opening and closing brackets, and then we send over the parameters. In our case, we are sending over a reference to self. So now we can save that, build it, and here you can see we have test printed out in the console. Now, in the next lesson, we are going to be looking at how we can create more advanced functions, sending over multiple parameters and having it outputs, okay, returning values for us to then utilize later on. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to continue learning about functions. Now, let's look at how we can create a function that has multiple parameters as well as an output that we can return, okay? So basically, our function is not just a one-way path, it is going to send out information and then receive something back. So what I'm going to do is I'm going to create a function here, and it is just going to be a very simple function. All it's going to do is subtract one number from another. So here I'm going to create a function. We're going to call it subtract, and we're going to have our parameter of self, of course. Now to add multiple parameters, we add in a comma. Our next one is going to be A, and our next one is going to be B. Then we can end it off with the end keyword. Now, it's also important to know that these parameters we send over are only variables that exist in the scope of the function, okay? So for example, I can't go over here to the final function and start referencing the A variable, as that is not going to work, okay? It's not going to know what A is. A, B, and self only exist within the scope of this function here. Now, what we can do is we can create a variable. Now, to create this variable, I'm going to use the local keyword, okay? And I'm going to create the variable called sum. We'll call it result, actually. And this is going to be equal to A minus B. Now, we are using the local keyword here to define a variable differently to how we done it before. Before we were doing self.result to create the variable. Now creating a variable via self.result, that will create a result variable and basically add it to the memory of our script component. So down here in final, we could access the result variable. Down here in fixed update, we could access the result variable, but we don't need to do that. Okay, this result is only really going to be needed inside of this function. So we can define that instead with the local keyword, which means it will create a function, it will create a variable called result, but it will only exist in the scope of this function here, okay? So it's sort of like a temporary variable, very similar to a parameter. Then we can simply return the result. So here I'm going to go return result. And this is basically going to get this result value, and it's going to output it, okay? That's what the return keyword does down here. Now, it's also important to note that you don't really want to be adding in any code underneath result return, because once return gets called, that will basically end the function, okay? That basically defines the end of the function, and that's where it cuts off. You can even use the return keyword to cut off a function early if you have already done what you needed to do. So you can have multiple different returns throughout a function based on if certain conditions are true. Now, up here in init, we're going to create another variable, and we are going to define it as local. We're going to call this our, we'll just call it our num, and this is going to be equal to our subtract function. Now you can see it automatically creates the first self parameter as well as a and b for us right here, which is very nice. But we need to replace a with a number. So let's just say we want to do 100. And for b, we'll make this 20. So we're doing 100 minus 20. So what we're doing here is we're basically calling this subtract function. It is then going to return the result. So this is essentially going to be the number 80. You can think of it like that, okay? So we are basically setting num to be equal to 80 right here. We can then print out that result. So print out the number. And if we build this, you can then see down the console, we have 80 printing out here very nicely. Now, why would we do this instead of just, having num equal 100 minus 20, okay? We can just do something like this, which is, it's going to have the exact same result. Well, we do this because functions are reusable, okay? And we don't have to basically write out all this code every single time. So, for example, if we were to create a function that was a bit more complex, let's create a new function right here, call it complex, okay? We'll send over the self parameter. We'll also send over an A and a B. We'll also send over a C as well. How about that? Now what we can do is basically, I'm just going to make this function very complex, do a lot of things in here. So what we're going to do is we'll create a variable called, we'll call this run results. And this is going to be equal to A plus B plus C. And then what we might also want to do is down on a new line, maybe go result equals result divided by 2. Then we might want to go result equals result plus A, okay? So what we're doing here is we are basically just doing a lot of different calculations, okay? Something that before would take up multiple lines. We can then return the result. And then up here for our number, we can have this equal to our complex, sending over self. A could be 2, B could be 8, C could be 12. Now, if we run this, you can see down here we get our number, 13. But you could be saying, okay, this is basically the exact same thing we've done before. We are simply replacing all this code here with just a function call, but it still takes up the same amount of code. Well, what we could then do is do it again. Maybe we'll create another variable down here, local A equals complex. Send over a bunch of different numbers this time. So something like this, print out the result here, and this is going to return us basically 2 different numbers. Now, the great thing about functions, like I said, is that it is reusable, okay? We don't have to rewrite this code each and every time we want to use it. Rather, we write it once, okay? It's essentially a blueprint that we are then calling whenever we wish, okay? And later on, you might have very large functions that could have perhaps 100 lines of code in it that you need to run, let's just say, dozens of times per second, okay? And otherwise, if you weren't using a function, that could take up so much space. Whereas here, we can compress it down to one single function and call it as many times as we wish, sending over just the parameters that are needed. Okay, so now I have a bit of a challenge that I want you to complete, okay? First of all, I want you to create a function called has1. Now this function is going to have 2 parameters. It's of course going to have our self parameter as well as a parameter called score, which is going to be a number that we'll send over. And inside of this function, I want you to check to see if the score is greater than 100. If so, return true. Otherwise, return false. So this function is, instead of returning a number, it's going to be returning true or false based on the parameter we send over, okay? So have a go at creating that, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. So how are we going to do this? Well, first of all, we need to create the function keyword. We then give our function the name of has1. Then inside of our parentheses here, we define not our variables, but our parameters, which are basically temporary variables. The first one is going to be self, which is a reference to whatever instance of this script is calling the function. We then send over our second parameter, which is going to be score. Then what we do is we create the end keyword, and we can then create the body of the function. So inside of this function, we need to check to see if the score is greater than 100. If it is, return true. If it is not, return false. So the way we can do this is by having an if statement. So we can go if score is greater than 100, then what we're going to do is return true. And then we can put in the end right here. Okay, so what we're going to do is this function is going to run. Now, if score is greater than 100, then we are going to return true. Now, otherwise, we aren't returning anything at the moment. So what we need to do is we need to add in an else if, or just else actually, and return false. Okay, just like that. So what we are doing now is if score is greater than 100, return true. Otherwise, return false. Okay, so now if we go up here to our init function and we create a variable, call it 1, and this is going to be equal to has 1. And the score will send over, let's just say 80. And then we will print out the 1 result. Now, if we build this, you can see down the console, it is printing false. Whereas if we change this score to, let's just say 150, build that, it prints true. Now, something else we can do here to tidy up our code just a little bit is inside of the has1 function, we don't actually need the else statement here, okay? Else statement, this only runs if the above condition is false, which generally you would want to have if you want one or the other to call. But instead what we can do is we could just end this function here and add return false down at the bottom. Now you may be thinking, okay, we're going to check this condition, it's going to be true, so we'll return true, but then the code's going to keep on running and then call return false. Well, that's not the case, because the great thing about a return statement is that it essentially ends the function there. So when we are returning true here, we are essentially cutting off this function, we are stopping it right there and not doing anything more with it, okay? So we don't need an else statement here to run return false if this condition is not true. You can still do it, of course, if it makes more sense, but generally, we can have a return false here, and it is going to run the exact same way. Hey everyone, in this lesson, we are going to be looking at message passing inside of Defold. Now, message passing is a core fundamental of the engine, and this is how basically we can communicate with other game objects in our game, because right now everything we're doing is sort of self-contained to our own script, so allowing ourselves to communicate with other game objects is going to be necessary, especially in games. So what is message passing and how do we actually do it? Well, as you can see in this example here, we have a player and an enemy, and they can basically send messages back and forth. You know, an enemy might send over a damage message when they get close to the player might knock them back. And yeah, there are many different ways that we can utilize this. So how do we actually use it? Well, what we can do is use the msg.post function to send out a message to a given receiver, okay? Now, we have to send over two parameters. We have to send over the receiver URL and a message ID. Now, both of these are strings. So, for example, if we have a door game object, we would get that door's URL, or we would actually get that door's script's URL. So let's just say we have a door game object with a script component that is named door. Well, this is how we would access it. We would get the door game object hashtag, which is basically our way of getting access to its components, and then we would get the door component, and then we would send over the message ID of, for example, open. Okay, this is a custom message ID that we are sending over. And then over on the door script, we would receive messages with the on message function. Now, we've actually already have this created, so we have seen it before. But basically, inside of this function, we would have an if statement like this, where we would check the message ID to see if it is open. And then if that is the case, we would then do whatever we needed to do. So this is basically a way of sending out messages from one script to another script, okay? And we can send over any sort of data that we wish. So now what we're going to do is hop over inside of Defold and have a look at how we can set this up. So here we are. Now before we continue, let's actually go and create another script and another game object for this to actually work. So what we're going to do is we are going to go to our main collection here. On the top right corner, we're going to right click on collection, add a new game object. This one I'm just going to call our door. Okay. Let's actually name it something a bit different. Let's maybe name it house underscore door, like so. And then we want to create a script, a door script for this. So I'm going to open up our main folder, scripts, right click on script, new file, go down, oops, not that one. We want to go down to script down here, and we're just going to call this one door. Now, inside of this door script, we don't really want to worry about any of this, so I'm going to delete everything except for the onMessage function, okay? Because onMessage is what we want. Now, before we continue, let's go ahead and attach the door script to our game object. So we'll right click on the game object, add component file, select the door script, click OK, and there we go. Now, what we need is what's known as this component URL, okay? Sort of like a website which has a URL that is basically a way of finding a specific web page, okay, an address. That's essentially what we have here with a URL. So if we select our door component, you can see down here in properties, we have an ID, which is its name, and then we have a URL, which is house door #door. So what this basically means is this is basically the URL in relation to the collection, okay? So from collection, we then have house door, and then in house door, we go hashtag to access its components, and then we're accessing the door component. So this is the URL that we need to basically use if we want to find this specific door script component. Now, what we're going to do is inside of our player script, up here in the init function, we are basically going to send out that message. So to send out a message, we are going to go msg.post. We then want to have a receiver and a message ID. The receiver is going to be that door's URL. So as a string, we can go door, or house door, hashtag to go into the components, door. So we are now targeting that door script component. For the message ID, this is basically just going to be the name of the message we are sending over. This can be whatever we want. We're just going to call this one open. And then what we can do is save that. In our door script, we then want to go to the onMessage function, which gets called whenever it receives a message. And here we are going to go if message ID, which is the name of the message, equals, and then we want to basically write out the message name, which was open. Then what we're going to do is print door is now open, and then end that off with an end keyword right here. But there is something wrong, and that is, even though we are defining our message ID as a string here, it's not technically a string when it gets sent over, okay? Rather, it gets converted into a hash value that we need to convert from a hash into a string back again. Now, how do we do that? Well, basically, we just need to wrap this open string inside of a hash function right here. And that will basically convert this string into a hash, which is what our message ID is. So now what we can do is we can save that, we can then build, and down here in the console, you should now see it says door is now open, which is great. Now, something else, and that is we can actually send over data with our message, because right now we are basically just calling this message, sending it out, and telling the door that, okay, we want to call the open message, but that's not really sending over any data. So how can we send over some data that the door might want to use? Well, let's just say we want to send over, for the sake of it, a score, okay? We don't really need to be sending a door a score, but let's just say we will. So I'm going to create a variable here, self.score equals, let's just say 50. Now, the reason why I'm using the self keyword here and not local is because score is a variable that we generally want to have across the entire instance of our script, because later on we might have a function which increases our score, might have another function which checks the score. So having this score variable basically stick to the script component is going to be necessary. And then what we can do is to send this over as a value or a parameter, I guess you could say, is we're going to add another comma. We're then going to add an opening and closing squiggly bracket like so. And then in here, we are going to define the name of the value that we want to send over. So let's just say we want to have score, and then we'll go equals, and then we give it a value, which is going to be self.score. Now, to add multiple, you can just do a comma, add in another variable. Let's just say we want to send over a value that is called door size. We can send that over as maybe 10, something like that, okay? So these are the values that we're then sending over through the message. Now what we can do is inside of our door script, we can access these by basically going message dot and then score, or message dot door size. So what we can do is let's print that out. So here we'll go print message dot score. So now this is going to access that score value that we are sending over and print it out. So as you can see, door is now open and it's printing out 50, which is great. Okay, so you can see how messages are pretty powerful. Now, it's not just custom messages we can send over. We can also listen here for messages that are built into the Defold engine, such as collision detection or other custom engine-based messages that we might want to utilize, such as acquiring input focus for detecting inputs. And these are things we'll be looking at in the future, as there are a large number of these that you'll be using across your game development journey. Congratulations on completing the course. We just finished looking at the Defold engine and the Lua scripting language. Okay, so by now, hopefully you have a bit of an understanding of how to use the engine and also have the fundamentals of scripting in your mind, ready to go to create your first game. So in this course, we looked at first of all installing Defold, then an overview of the editor, what each of the different panes do. We then looked at the building blocks of game objects, components, and collections, and how they work together to basically construct our game. We then also looked at scripting, okay? We learned the Lua coding language, and we also looked at it from the very beginning, okay? So no prior knowledge was indeed required. Zenva is an online learning academy with over 500,000 students. We feature a wide range of courses, for people who are just starting out, or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with included course files. So thank you very much for following along with the course, and I wish you the best of luck with future Defold games.